So, hello folks, welcome back. The next topic is actually going to be quite complicated. So, if you haven't taken a break and you've been listening to the lectures continuously, you might want to go get a drink or something and kind of rest up before you get into this section. This part of the lecture is talking about the process that we call ossification. The word osteo stands for bone, you already know that. So, ossification stands for creating the bone. So, so to create the bone, there are two ways that can happen. One is called intramembranous ossification, and that's happening in certain type of bones like clavicle, mandible, skull, and face. So the bones that are flat. And then there is endochondral ossification. That is for development of limbs, vertebrae, hips, so the long bones, the ones that look like this. So ossification, intramembranous ossification, you start off with the membrane, and that's what you have here on the skull. And then you have this thin sheet of membrane, and then inside that bone size starts to grow. So the word intra means within, and inter means between. So hopefully you remember that. Intra means within, and then the word inter means between. So intramembranous is happening within the cartilage. So you really have to commit this to memory. So basically how you form regular shaped bones like the clavicle and flat bones in the skull, the ones on your face. And that's how the fetus is going to make those kind of bones as well. And then there's endochondral ossification. The word chondro comes from cartilage. We learned that before. Endo stands for inside. So that's what's happening here in these bones, long bones. So it's like you make kind of a gelatin mold that's made up of cartilage. So there's this gelatin mold that's made up of cartilage. I'm trying to draw a long bone here. And then the bone starts to form in the middle here. And then it starts to grow in both directions. So that's what's happening here. And eventually it keeps growing and growing. And then this is what it looks like in the end. So what you're seeing here is the bone inside the endo. Endo means inside the bone is inside the cartilage, so it starts to spread, and that's how you make long bones, the hip bones, vertebrae, femur. So these two processes here are necessary for you to form all your bones. And then you have, so when there's a baby, newborn baby, they they have these skull bones, they have this soft spot on the skull bones. And we've been talking about the skull bones in the lab. So some of the bones, they're like frontal bone, occipital bone, parietal bone. So those bones are not fused together at birth. So I pulled up this skull. So these bones, they are not fused. There's this soft spot. And then they start to grow. The bones, they start to grow in this direction and then in this direction. And eventually they're going to fuse together. But there's this soft spot. But that's the intermembranous growth, that's ossification that's happening. So there's the soft membrane, and then eventually it's going to form the skull. But there's the soft spot, they're not fused together for the development of the brain and the growth of the brain. So that's what's happening in the skull. And then we have the long bones as well. So the soft membrane will eventually form the skull in the fetus, and then you have these mesenchymal cells, which are stem cells, and they'll start forming osteoblast. And you already know what osteoblasts are. If you don't, please go and make flashcards for those terms. So basically what's happening is that you have this membrane in the skull. I drew the membrane here. So you have this membrane in the skull. And then that membrane, you're going to have the osteoclast and osteoblast, both cells. But here we need osteoblast, they build the bone. So they start to build the bone, and it starts to kind of go like this. And there's going to be matrix, and inside the membrane. So this is basically center of ossification, and then it just starts to make bone. And osteoblast starts to lay down more and more matrix starts to grow, and then it starts to grow in this direction. Here, same thing for this bone here. And eventually that sheet will get bigger and bigger until it gets the same size as the membrane, and it'll be the same shape as the membrane. I think I'll have other pictures to show you, but same thing what's happening in the long bone here. It starts to grow, and it was growing until it became the same shape as the membrane. And then eventually in the skull, it'll turn into occipital bone or frontal bone, or whatever bones are there, temporal bone. And then there you have multiple places where these membranes are, and eventually they're going to meet in the middle, and that's where you have the sutures in the skull. And when we look at this in the class, you'll see the sutures, and it starts off with the membrane of the flat sheet, and then ossification happens as the matrix is being laid down by osteoblast. And then eventually blood vessels will go in there because you need to feed the cells. So blood vessel will go in there and they'll grow some more. Eventually it's going to form the shape of the skull bones, and that's what we're looking at. So there you have it. This is going to the fetus skull, and if this was a membrane in the matrix, so eventually it just forms all the bone until it reaches the end of the membrane. Or once it hits another bone, it stops. And that's why you end up here with the sutures, and you also have the soft spot. So when we're talking about the baby, newborn baby, we always tell people to be careful with the skull because there's a soft spot and there are holes in there. And that's because those bones haven't fused together yet. The brain needs to grow. If the brain's fused, then if the bones fuse together, then the brain can't grow anymore. So children who are born with the fused bones, they have to do a skull surgery where the surgeon needs to cut open those pieces and leave them unattached so the brain can grow. And then eventually those bones will fuse, and then the brain can be protected. Okay, so I do realize I'm going pretty fast here. So please, again, if this is overwhelming for you, you might want to pause the video. You kind of want to walk away for a little bit and then come back. And those of you who are keeping track, let's go into the next section. Also, you can look up ossification videos on YouTube. If this is not making sense, maybe look up something that has animation, so it'll make a little bit more sense. Okay, so this is showing the ossification of the bones, intramembranous ossification. This is what I was trying to say. So what's happening here is they start development of ossifications and happens, and then or development of ossification center happens, and osteoblast they start to secrete the matrix, and calcium and other mineral salts are deposited, and it keeps growing until it reaches the end of the membrane, and then the blood vessels go in. So this is what I was talking about in the last slide. So you have these mesenchymal cells, osteoblasts, fibroblasts, they are forming organic matrix. And then the osteoblast starts to form bone in centers of ossification. And then centers of ossification enlarge, eventually fuse, and gaps remaining after birth are called fontanelles. And we're talking about a fetal skull here. So in here, there's a center of ossification, and then you have the osteoblast laying down the matrix, and they start growing, and they are going to keep growing, and they're being trapped in this area until they reach the membrane. They're going to keep growing, and they grow into the cartilage. But then because they need the nutrients, the blood vessels go in and feed all these osteocytes, and that are going to be inside of these lacunae, you can say. So it enters the center of ossification was starts to fill in, starts to go towards both ends, and let's see here. It starts to kind of go towards both ends, and these are the osteocytes inside the lacunae, and they're forming bone. And then the blood vessels start to get trapped in because all these osteocytes need nutrients. And then that's how formation of the spongy bone happens. So that was just a summary of why the cartilage and the matrix and the intramembranous ossification happening with those, and then the blood vessels eventually go in. So let's see, this is formation of the endochondrial ossification or formation of the long bones. Okay, so in the long bones, it has to they start forming the bone in the center. So you have this model of hyaline cartilage, and then in the center, that's where bone ossification starts. This is called primary ossification center. We're going to notice you also have secondary ossification center. So step one is the chondrocytes enlarge, and they die, and then so these are chondrocytes, and then the matrix calcifies, and then there are cavities forming within the cartilage. And then blood vessels, they start to grow and grow cartilage, and you can see that there is blood vessels going there, and then osteoblasts form bone at the surface of the shaft, which is the diaphysis shaft. We were calling it diaphysis. And blood vessels enter the cartilage. They bring fibroblast, turns to osteoblast, and bone tissue spreads towards the epiphysis. So bone ossification is happening, and so if it started right here, then it's going in this direction and in this direction. That's how it's happening. And then you also have secondary ossification center that's present in this area. So that's above the epiphysis. That's epiphysis. And then this area that's pretty thick, it's called epiphysis plate. That's the epiphysis plate. So the medullary cavity, so the cavity in the middle, that's the medullary cavity. So you're gonna notice that as the long bone is blowing up here, getting bigger, the center also has to be empty for the bone marrow, and that's where the term remodeling comes in. So remodeling means you reshape the bones. So what's going to happen is that osteoclasts, they're going to go in and they're going to eat away at the center to create this empty space in the middle. So when you're going to have, that's where the bone marrow is, and that's called remodeling. Remodeling means reshaping the bones. So that has to happen here for medullary cavity to form, basically, so the blood vessels can go in and feed the cells. Again, you have two centers of ossification, primary and secondary. Primary is in the diaphysis, and secondary is above the epiphysis. They're going to do the same thing. They're going to grow some matrix, and the matrix will spread, and until they reach towards the epiphysis, this matrix is going to spread, and then this is going to spread towards the diaphysis. And again, you have the epiphyseal plate, which is the growth plate. So epiphyseal plate is the growth plate. Let me write that for you. That's the growth plate. But it depends how thick this growth plate is, depending on if you're looking at bones of a child or an adult. So adolescents that's still growing, they're going to have big growth plate or big band of cartilage, like wide, thick band of cartilage, because they're still growing. But people who are older, they're going to have a very thin line. When they're done growing, they don't have cartilage anymore. They just have a line. We don't call it plate anymore. We call it epiphyseal line. So this is step 4. That's remodeling. That's what's happening when the medullary cavity is forming and the osteoclasts are eating away at the bone. So in the lab exam, you have to know the difference between the epiphyseal plate and epiphyseal line. So I will ding you for this. If you were given an adolescence bone and I point to this part here and I ask you what it is, you want to call it epiphyseal plate or cartilage. But if I give you a bone from an older person and you see there's only a line there, then you have to call it epiphyseal line. So epiphyseal line is what's left over when you're done growing. So that's what happens in an adult. Early in 2020, when they're 2021. And around that age, there are, and then a couple of years later, um, when you're done growing as a child, then so if a child goes and gets an X-ray, you're going to notice doctor can take a look at this plate, how thick this plate is, and that can tell how tall that person is going to be. If there's a lot of growing, that's gonna happen, or if it's pretty thin, then maybe the bones are not gonna grow that tall. But when they get older, this is an indication of how much of that epiphyseal plate is left. It's just gonna be a line that's gonna be left. So if you look at senior citizens' bones from all the years of taking away matrix and pulling matrix back, taking away calcium, putting calcium back, all this stuff replace this line. So you're going to have something that's very thin. And when a person dies, they can look at their bones and they can see if it's a line or if it's a plate. That'll tell if the person was older or the person was adolescent, because if there is some growth plate left, that means they were still growing. And then the replacement process begins in epiphysis, which has the secondary centers of ossification. And then there is spongy bone in epiphysis, the remnants of fetal cartilage between the epiphysis and the shaft. So there is some spongy bone in this area. This is the overview slide. Okay, so what's happening here is that the bone can grow in 2 different directions. You can make the bone longer. And if you make it longer, that means the bone grows towards the epiphysis plate. And then going towards the proximal epiphysis. And so it's growing towards this direction, proximal, and then also towards the distal epiphysis. This is going to give you the length on the bone. On the other hand, you can make the bone wider. If you make the bone wider, what's going to happen is the width gets wider, and you need to make sure the center keeps up with it. So what I mean by that is you need to make sure there's space, there's medullary cavity in between that's going to have all the blood vessels coming through. Because if that doesn't happen, this whole thing is going to become solid. It's going to become solid bone, and there's not going to be any space for the bone marrow. And then the body will be too heavy and we won't be able to move it. So one of the reasons you have this medullary cavity is to lighten up the bone so it can make it less burdensome to walk around. And basically outside is the compact bone and then inside is the spongy bone. So as it becomes thicker, you have these osteoclast cells that are going to eat away at the bone on the inside, so at the endosteum. So they're going to eat away, making the space wider and wider and keeping up with the growth of the bone. And that's called appositional growth. So that's what's happening here. We have a bone, and you take a cross section. This is infant, child, young adult, and adult. You're going to notice as the bone gets longer, as the person grows, the medullary cavity also gets wider, and that's done by the osteoclast cells. They're going to reabsorb the bone, and that's how the medullary cavity is going to get wider. So that's called appositional growth. It grows in diameter and thickness of the bone along the shaft. So inside is getting eaten away to make space. Bone growth. The last thing I want to talk about is bone health and damage to the bones. Good bone health is having nice, thick, compact bones. And it's dependent on lots of things. And, obviously, main thing is your genetics and your diet. So if you're getting enough vitamins, what you need to do is have things like vitamin A, D, and C. But even though you might be eating these vitamins, they might not be getting absorbed. That's because you need hormones to absorb them. Two hormones that help to absorb these chemicals are going to be calcitonin, which is made in your kidneys. So this one, and then parathyroid hormone. PTH stands for parathyroid hormone. This hormone is made on the posterior part of your thyroid gland. If you don't have this, or if you don't have calcitonin, it doesn't matter what your diet is, because you can be eating all these vitamin supplements, but your body doesn't know how to absorb it because you don't have the hormones to absorb it. So you can eat as much calcium, drink as much milk you want. You can eat as much cheese, yogurt, dairy to get the calcium and phosphorus and magnesium and all that stuff, but none of these things will get absorbed in your body unless you have hormones for it. So people who have osteoporosis, that's a disease. Let me write that down for you. So people who have osteoporosis, hopefully I spelled it right. I think there's another O here, maybe. You can double check the spelling. So people who have osteoporosis, they have bones that have pores in it. Actually spelled right here. So they have these holes. It looks like, they have these big spaces, which makes their bones a little bit more brittle. So if you suffer from this, and you can do an x-ray to see how dense your bones are, and looks like if your density index is very low, then the doctor is going to check your hormones levels first, your PTH level, your calcitonin level, to make sure that you're absorbing the minerals like calcium. And then they'll ask you about your diet and make sure that you're getting enough calcium. If you're not, they might tell you to take some supplements. So people who don't exercise, they also they're more prone to getting osteoporosis. And because if you don't exercise, your body's saying, oh, well, he's sitting on the couch all day. I don't think he really need to have strong bones. How about I go in and steal some of his calcium so I can use it in other parts of the body? So if you don't exercise, what you're telling your bones is that they don't need to be hard. They can be soft. And so first thing you need to do is have a good diet. And then next thing you need to make sure your hormone levels are okay, and you need to exercise. So the next thing you need to do is have an activity level. These are the minerals I've been talking about: calcium, phosphorus, magnesium. So next thing is to have the activity. So you need to go run, jump around, go to the gym, and that'll give you nice strong bones. And some of these things are out of your control as you get older. So what's going to happen is that your osteoblast and your osteoclast activity is so osteoblast activity kind of goes down faster than the osteoclast activity. Again, osteoblasts are maintaining the bone, making the bone, and osteoclasts are eating away at the bone. So if osteoblast activity is down, means the bone is not being, it's not as strong, or it's not being maintained as well. It's not being laid down as fast, and then osteoclasts are eating away at the bone faster. So osteoclasts eat away the calcium, your osteoblast replaces it. But as you get older, osteoblast activity starts to slow down, and these guys aren't as active anymore. So when the osteoclasts eat away at the bone, and the osteoblasts don't replace it fast enough, and then you get weak bones. There are also other factors, you can look it up. Women are more prone to osteoporosis. Certain races of people are more prone to osteoporosis. we try to come up with a reason saying maybe it's their diet, maybe they don't drink enough dairy, but the most obvious reason would be genetics. That's what's causing differences between different races of people. And if you get diagnosed with this, your hormone levels are good, then they'll just recommend you to take some calcium supplements and exercise. So I think we are almost at the end here. So bone repair. So last time we talked about this is what happens is when you break a bone. So broken bone is called fracture, fractured bone, repair of a fracture. So some of the instructors, they will kind of show these x-rays of fractures to students, ask them to identify the type of fracture it is. So I'm not going to do that. So if you have a very mild fracture, it could be just a bruise. If you hit your bone, it could be a bruise. So you might not even know that it's damaged until the periosteum starts to do something. So sometimes let's say there's no fracture and it's just a little bit of a bruise. It might be flamed. It might not show up on an x-ray immediately. But a very small fracture, like a hairline fracture, it could be just a line, and then you know, then there could be a fracture that breaks the whole bone. So there are differences. It can be very small, it can be very big. But anyways, the first thing that's gonna happen is if you survive, is the blood that's gonna go there like this, and it goes in there. And it's called hematoma. That's called hematoma. And the word hemo stands for blood. Heme. Toma refers to collection of something. So hematoma and the blood is basically trying to get rid of some of the debris that's there, which refers to the garbage. And because there are white blood cells in the blood, it goes there and makes sure there's no bacteria, if there's any debris, it starts to eat away at that and make sure that waste kind of, gets taken care of before it starts to heal. So it's trying to heal the fracture. So next thing that's going to happen is after you get this hematoma, you have osteoblasts that go in there and they start to fill in the hematoma with the calcium. So they're supposed to put matrix in there. As the hematoma fills in, you'll notice the shape of the bone is going to change. It's going to be a little bit different. So the hematoma fills in, it causes some swelling. Matrices basically mimic the shape of the swelling. So if you work with your hands a lot, you create calluses on your palms of your hands. That's like thickening of the skin. If you have thickening of the bone, then that's called callus as well, callus of the bone. So your body doesn't like to generally leave it like that. So what happens is when you have fractures, you have hematoma that gets filled in, and then you get a callus, and next thing that happens is your osteoclasts go in and they'll shave down this callus and they'll make it flat because osteoclast consumes the calcium and eventually you'll get a nice straight bone. And if it was not broken, completely, but that only happens when you're a young adult. I don't know how many people here have broken their bones, but when you're a kid and and you break a bone, it's going to heal nicely. And there hopefully won't be complications. But older folks, if young, maybe young adults break their bone, there might be less ability to remove this callus. So as kids, the bones can heal nicely without calluses, but as you get older, we don't have the ability as older person remove the callus in the same way anymore. So that's so breaking the bone as an elderly person is going to stay with you. So that's something about being a child. It's like a superpower which allows you to remove the callus to the point where if a kid don't get access to the medical care when they break a bone, the bone starts to kind of mend on its own, and it may look a little bit crooked, but the arm, and let's say it's the arm bone, it's going to heal. It's going to look maybe crooked. A young child, if it's a young child, depending on how big the angle is, they might be able to actually straighten the bone and it can straighten completely. But as you get older, that superpower kind of goes away and it might not um, heal properly and might leave a callus because the osteoclast might not be as active. So that all that can happen. So that was our tour of skeletal system. Um, I'm not going to lecture on chapter 6 and 7 because we're going to cover those in the lab. So we will use those chapters to reference the names of the bones. And then for the second lab exam, you're going to be tested on the bony markings. So you'll need to work on chapter 6 and 7, bony markings and bones. And then next one will be joints, chapter 8. So I'm going to stop this video here and I'll start the next one.